Okay, so welcome to this video looking at the first unit in the AS Pure Maths course. We're going to be focusing on the algebraic expressions with these 6 topics shown on the screen. So you will notice a lot of crossover here from GCSE, obviously a lot of topics that have sort of progressed and been used again in this first chapter of the AS Pure module. So hopefully a lot of these you'll be comfortable or happy with from GCSE, but if you're not, obviously there's an overview here for you to have a look at. Now what you'll notice is I have bookmarked each of these topics, so you can go into the bookmark and skip your way through. Likewise, if you go into the description, you'll notice that there is a revision video for each of these topics, and some of these you might even recognise if you followed me along with the GCSE course. So that's how this video is going to work. It's nice and quick, but if you do need to do any further work, please do check out those videos in the description. And again, if you find this useful and helpful, please do like it, please share it with your friends, and obviously please leave a comment and just let me know if there's any specific content that you'd like me to cover across the AS Pure curriculum. So anyway, with that being said, let's get started. Okay, so we've got larger coefficients of x here. We've got the 2x and the 3x, and I'm going to start by expanding these two. So let's write that out. We've got 2x plus 3 and 3x minus 2. So we know we're going to get the 6x squared here when we do the first two. So 2x times 3x gives us the 6x squared. And let's have a look at those middle two. So we get minus 4x plus 9x and those middle two. So minus 4 plus 9 gives us 5x, so we're going to have plus 5x, minus 4 plus 9, and then we're going to get minus 6 at the end. There we go. So just save you a little bit of time if you can do this. And let's stick that in a bracket, and we're going to multiply it by the x minus 4. There we go. We can do it all from here now. So just following the same process as before, 6x squared times x gives us 6x cubed. 6x squared times negative 4 is negative 24x squared. And then moving on to the underneath, 5x times x gives us plus 5x squared. And 5x times negative 4 gives us negative 20x. And then on to the negative 6 to finish it off. Negative 6 times x is negative 6x. And negative 6 times negative 4 is positive 24, and then we just need to tidy all this up again. So we've got the x squareds there and the x pieces here, and let's just rewrite all that nice and tidy. So 6x cubed, negative 24 add 5 is negative 19, so negative 19x squared. Negative 20 take away 6 is negative 26, so negative 26x, and then plus 24 at the end. And there's how to do that one. So keep it all really nice and tidy, expand whichever two you want to start with, tidy it up with your third bracket at the end once it's been simplified, and then just go step by step really nice and carefully before you tidy it all up at the end. And remember what your answer should look like. You will get these cubes, the squareds, the x, the numbers. Sometimes they might cancel each other out, but in none of these they have. So when we're simplifying an algebraic fraction, we're looking for a common factor on the top and the bottom. And when it comes to algebra, to find a factor in algebra, we can factorise to find a factor. So if we have a look at the top, and we just need to factorise both of these. Now, the expression on the top there has an x in both. So we can factorise this by x. No numbers in both, but we can factorise it by x. So if we take x out of the bracket, we would have x, and then inside the bracket we'll have x plus 5. Okay, x plus 5. If we do the same on the bottom, we've got a quadratic on the bottom, so you need to know how to factorise quadratics here. But we've got 1 and 10 or 2 and 5 as our options to go in our double bracket. And in order to make 7 there in the middle, we want plus 2 and plus 5. And here we go, x plus 2 and x plus 5. There is a little bit of a hint there in terms of the factors we'd be using, because obviously we had x plus 5 on the top, but it's not always going to be the case that we'll get that. But obviously, so we still need to be able to factorise, but there is a little bit of a hint there that there was going to be an x plus 5 in one of the brackets. Now there's an x plus 5 on the top and the bottom, so essentially what we can do is we can divide the top and the bottom by x plus 5, which would cancel out these brackets here. And if we cancel them out, we just need to write what's left. We have x on the top, and on the bottom we have the x plus 2, which you can either put in the brackets or leave without the brackets, it doesn't matter there, but our final answer is x over x plus 2. Right, let's have a look at another one. Okay, so we've got another algebraic fraction here that has already been factorised on the bottom. So actually, let's have a think about how we'd approach this. Now, we want to cancel off a common bracket or a common factor, and the top and the bottom both divide by x plus 2. So actually, if we imagine what this would look like if we were to sort of expand that bracket or just write it as a double bracket, we'd have x plus 2 on the top, and on the bottom, it's x plus 2 and x plus 2 as a double bracket. There we go. Right, so if we cancel off one of the x plus 2's top and bottom, we've just got to be careful this time because we can cancel that one off and it will disappear, but not to forget we are dividing by x plus 2, so when we cancel the one off the top, it doesn't just disappear, but if we divide it by x plus 2, it becomes 1. So writing our final answer, we would have 1 on the top and x plus 2 on the bottom, which again, I'll just get rid of the bracket there, so 1 over x plus 2. So just watch out with these sorts of questions here when the factor is all that there is on the top. Obviously that does become a 1 there, it doesn't just disappear. Okay, so introducing some negatives. Same process though. We'll stick 2x in one bracket and x in the other as we've got a 2x squared. And again, writing down the factors of 10, so 1 and 10, or 2 and 5. Now again, one of them is going to double, so we could have 2 and 10, or we could have 1 and 20. Are we going to be able to make 9 out of either of those? No. 2 and 10 we could make 8, we could make 12, but we can't make 9. And then 1 and 20 we could make 19 or 21, but we can't make 9. So it's not going to be 1 and 10, which means it's going to have to be the 2 and the 5. Got to be a little bit careful here because we have got negative 9 in the middle, so we are trying to make negative 9, but similar process to when we were factorising before. So let's double one of them, so we could have 4 and 5, or we could have 2 and 10. There we go, just doubling one of them. So again, we're trying to make negative 9, so it's going to have to be 4 and 5. We can't make 9 out of 2 and 10, but we can out of 4 and 5. We've just got to figure out, okay, well, which one of these needs to be negative? And actually looking at it, look, we've got a positive 10 at the end, so they're both going to have to be negative. So it's going to have to be negative 4 and negative 5. So I just want to make sure that that number above the negative 4, the 2, goes in the bracket that's going to be doubled. So on the right hand side there we want negative 2, that's going to allow us to get negative 4, and on the left bracket there we'll put the negative 5, and again you can just expand that to just double check. So 2x times x is 2x squared, 2x times negative 2 is negative 4x, negative 5 times x is negative 5x, and then negative 5 times negative 2 gives us the positive 10 at the end there. And tidying that up, look, these two here do make my negative 9. We get 2x squared minus 9x plus 10, and it matches what we were looking for. Now for this one here, it says simplify this fully, and inside the bracket we've got 32x to the power of 5, and then outside it's all to the power of negative 2/5. Now obviously when it comes to these negative fractional indices, the negative there is going to do the reciprocal, the 5 on the bottom does a 5th root, and the 2 on the top is a normal power of 2. And both of these pieces we have to do to that power. Now when it comes to the 32, we can think about the 32 on its own for the moment, and we can do 32 to the power of negative 2 over 5. Now we can sort that out and deal with that first. Now the negative obviously flips it over, but before doing that and doing the reciprocal, I'm going to do the 5th root of 32. Now the 5th root of 32 is 2. Okay, so 2 times 2 is 4, times 2 again is 8, times 2 again is 16, and then times 2 again for that 5th time gets us to 32. So to start with there, we'll do the 5th root. I'm just going to write this down here, 5th root. So that's 2. Then we're going to have to square it because we've got the 2 on the top, so we need to do 2 squared. So that becomes 4. And then if I do the reciprocal there, it becomes 1 over 4, and that's what that negative power does. So that 32 there is going to become 1 over 4. So if I write that down to start with, I can write down 1 over 4, and then we'll deal with that power. Now when it comes to the x to the power of 5, we can obviously multiply the powers when we've got brackets like this, so we're going to multiply these powers together. So we've got 5 lots of negative 2/5, and 5 lots of negative 2/5 will be negative 10/5, okay, just multiplying that numerator by 5, and negative 10 divided by 5 is negative 2. There we go, so my power is going to turn into negative 2. So I can write that out here. We've got then x to the power of negative 2. Now technically that is the answer, that would be fine, but there are other ways of writing this as well. And obviously we can write this in a slightly different way because x to the power of minus 2 can also be written as, I'm thinking about this over here, x to the power of minus 2 can also be written as 1 over x to the power of 2, remembering that that negative power there does the reciprocal, so it's 1 over x squared. So I mean, we could actually write this in a different way. If we imagine x to the power minus 2 as 1 over x squared, we've got a quarter. Remember, these are getting multiplied together, so it's a quarter times 1 over x squared. And if we multiply those together, we get 1 over 4x squared. Now for this particular question here, it does just say simplify fully, so we can write it in either of these ways, but it might be for whatever reason we might want to just write it as a single fraction. So it's always good to be able to know how to write these in different ways. So there we go, we can also write it as 1 over 4x squared, or we could just leave it as a quarter x to the minus 2. But there we go, that's how we're going to approach some of these questions. Let's have a look at a slightly different one. Okay, so this question doesn't look very nice, but you're going to see we're going to treat this in a very similar way to what we did before. Now again, ignoring that x squared for the moment, let's just deal with what's in the brackets. Now everything in the brackets there is to the power of 2. So we've got the 4 that we need to do to the power of 2, and that's easy enough to do. 4 squared is 16, so we've got 16 there in the bracket. And then we can multiply these powers that are in brackets as well, or times them. And if you multiply negative a half by 2, you get negative 1. So that's going to be 16x to the power of negative 1. And again, obviously, you can write that working out down to the side. You've got minus a half, and you're going to multiply that by 2, or 2 over 1, which comes out as minus 2 over 2, which is minus 1. There we go. So there we go, that's how we can get our power, obviously just thinking about negative a half times 2 is negative 1. And now we can obviously put that in a bracket and we can think about that x squared on the outside. There we go. So obviously when we are multiplying, obviously thinking about the fact that the coefficient of this x squared on the front is 1, and then we just multiply this bracket out. So 1 times 16 gives us 16. And then we've got the x squared times the x to the power of minus 1. And remember, obviously, when you're multiplying with powers, you add these powers together. So we're just going to add those two together. So x to the power of 2, add the x to the power of minus 1, obviously just the powers there, becomes x to the power of 1. There we go, so 16x to the power of 1. And obviously we don't need to write the power of 1, so we can just write that as 16x. And there we go, that would be our final answer for that one. There we go, so something that looks quite nasty actually simplifies down to something that's nice and simple for us. Okay, so this question here doesn't look very nice at all. But again, we're just going to treat it exactly like we have done in the previous questions. We're going to deal with the top and then we'll have a look at the fact that it's a fraction. So that top bit there can simplify. So straight away, let's have a look at this. So on the top, we've got 2 to the power of 3, which is 8. And we're going to multiply those powers. Okay, so 3 lots of a half. And then again, you can just write that as 3 over 1 times a half. And you get 3 over 2, or 3 halves, there we go. So that's 8x to the power of 3 over 2. On the bottom, nothing simplifies there, so we'll just leave that as 4x squared. There we go. And now all we have to do is simplify this down. So looking at the numbers, we've got 8 divided by 4. 8 divided by 4 is 2. And then we are dividing with these powers of x. So when we're dividing, we take away the powers. So we've got 2x to the power of something. We just need to figure out what that is. So obviously what we've got there is we've got 3 over 2. And we need to take away 2. So we're going to take away 2. Obviously 2 is 2 over 1. If we want to write that in terms of halves, we'll have to just change that denominator there. Just obviously that'll become 3 over 2. Take away, and if we times both of these by 2, there you go, that becomes 4 halves. And when you take those away, you get minus a half. There we are. So just taking away those powers there, and you might be okay just doing that without obviously writing all the fraction working out, but obviously just to show you there that you can just obviously apply a bit of written methods as well. But there we go, we get 2x, and our power is going to be minus a half. And again, you might be able to just do 3 over 2, take away 2 in your head, but there we go. So 2x to the power of minus a half, and again, that is a final answer there, and we can leave it like that, but there's another way that we can write this. And obviously this is going to be important for thinking about it in reverse as well. So x to the power of minus a half, well, x to the power of a half is the square root of x. So that would be the square root of x, but it's a negative a half, so that would be 1 over the reciprocal of that, so 1 over root x. So actually what we've got here is we've got and 2 multiplied by 1 over root x. There we go, and don't forget 2 as a fraction will be 2 over 1. So multiplying the top there, we get 2 on the top, and multiplying the bottom, we get the square root of x. So again, 2 different ways of writing your answer. You can either write that as 2x to the power of minus a half, or 2 over the square root of x. Either one of those is absolutely fine. Although I do think it's important to be thinking about how you can write your answers in different ways, purely because, as I said, sometimes they might be going the other way round, or you might have a square root on the bottom and have to rewrite it as a power. So it is important to be able to write them this way. Okay, here we go. So expand and simplify this. So slightly different look. We've got a number in front of this 2 root 3 here. And also, this is a slightly odd one, because we've got a surd in here which isn't fully simplified. Okay, we've got a root 8 there. Now you don't have to simplify it at this point. We can see if we can simplify it later on. You wouldn't be wrong to simplify it now, but I'm just going to leave it and see what happens. Okay, so just take note, there are some slight differences in this question, but let's have a look. 5 times 3 is 15. 5 times negative root 8 is negative 5 root 8. 2 root 2 times 3, remember numbers times numbers, surds times surds, so it's just 2 times 3, which is 6, so plus 6. Root 2, and there's no root with the 3, so just root 2. And then finishing the last part off, it's positive times a negative, so I've got negative. I'm just going to work this out to the side. 2 times the 1 there is 2, and root 2 times root 8, so we get 2 root 16. Negative 2 root 16. And root 16 is 4, so that's negative 2 times 4, which is negative 8. Okay, well if we do that to the side here, look, 2 times 4, which is going to be 8. So let's just get rid of that working out there and put negative 8. Okay, we can start to tidy this up now. We've got 15 take away 8, which we can do, but these surds aren't gonna simplify now. So what I need to have a go at doing is first simplifying this, because we've got a 5 root 8 there and that can simplify. So again, I'm just going to do that to the side. 5 lots of root 8. So ignoring the 5, root 8 is root 4 times root 2, which is 2 root 2. And again, just remembering we did actually have 5 lots of that. So 5 lots of 2 root 2 is 10 root 2. So rather than writing this 5 root 8 here, I'm going to write 10 root 2. So I'm going to rewrite this question. I've got 15 minus 10 root 2 plus 6 root 2 minus 8. So 15 take away 8 is 7. And then minus 10 lots of root 2, add 6 lots of root 2, leaves me with negative 4 lots of root 2. Right, there we go. So slightly harder there. We've got little bits going on where we've got to just be careful to simplify. But there are little hints there that with spotting the root 8 to start with, that there's going to be some simplifying going on. Okay, so we are going to have to times by something slightly different. Now if we think back to algebra, there's this situation in algebra where we're expanding a double bracket and the numbers are the same. The numbers are the same, but the symbols are different. One's positive, one's negative. It's called a difference of 2 squares. When we expand this, we get x squared minus 2x plus 2x minus 4 at the end. And when we simplify this down, these two cancel each other out. So we only end up with x squared minus 4. Okay, so we're going to apply that same logic to this question. So we're going to apply the idea of using the opposite symbol in the bracket. So let's have a look. Now on the bottom of the fraction at the moment, we have 2 minus root 5. So I'm going to rewrite this over here. 3 over 2 minus root 5. So I'm going to times the top and the bottom by what's on the bottom here, but I'm going to change that minus, that negative symbol, into a plus. So I'm going to times the top by 2 plus root 5. I'm going to times the bottom by 2 plus root 5 as well. Again, we've got to times the top and the bottom because we're making an equivalent fraction. But this pairing here is going to eliminate the surds in the middle, and we'll see why. And there's a bit of a shortcut we can take once we know this. So multiplying the top out, 3 times 2 is 6, and 3 times the root 5 is 3 root 5. And that's the top sorted. Now on the bottom, and this is the only time I'm going to do it this way, but I'm going to show you how to start off with this. So we've got a double bracket, let's write it separately. We've got 2 minus root 5, and we've got 2 plus root 5. And this is what we need to expand for that denominator. So we have 2 times 2, which is 4. Then we have 2 times this root 5, which gives us 2 root 5. Then we have negative root 5 times 2, which is negative 2 root 5. And then root 5 times root 5, one being negative, so minus 5. Now when we tidy up the bottom there, these two cancel out, and then we end up 4 take away 5 on the bottom. So we have 6 plus 3 root 5 on the top, and -1 on the bottom. Okay, so normally what I'm going to only actually do is this part of the multiplication, the first 2 times the root 5. Sorry, the 2 times the 2, not that bit, let's get rid of that, not that branch. The 2 times the 2, and the last one we did, which is the negative root 5 times the positive root 5, because I know those two ones in the middle are going to cancel each other out. Now this is quite an interesting first one to look at because we have -1 on the bottom. And if we divide by -1, it's almost the same as dividing by 1, but it's going to flip the signs of the numbers on the top. So actually I can simplify this further. 6 divided by -1 is -6, and that positive 3 root 5 turns into -3 root 5. That's quite an interesting one there to start off with. When you do get -1 on the bottom, we can actually get rid of that denominator completely. Okay, let's have a look at another one. Slightly harder ones here, purely because we've got this little 3 in front of the root 2 now on the bottom, but we're going to take the same process. So I'm going to times the top and bottom by what's on the bottom there, but flipping the sign. So I'm going to times the top and bottom by 5 plus 3 root 2. And then again 5 plus 3 root 2. So 2 plus root 2 on the top, multiplied by 5 plus 3 root 2. And then on the bottom, we have 5 minus 3 root 2, multiplied by 5, I don't want to put the multiply in there, because I'm speaking it as I say it, multiplied by 5 plus 3 root 2. And then again, just take this nice and slow, so 2 times 5 is 10, 2 times 3 root 2 is 6 root 2, root 2 times 5 is 5 root 2, and root 2 times 3 root 2 is 3 root 4, or 3 times 2, again you can write that slowly, 3 root 4, which is 3 lots of 2, which is 6. And there's the top, and then the bottom I'm going to apply that little shortcut, so 5 times 5 is 25, and -3 root 2 times positive 3 root 2 is negative, 3 times 3 is 9, root 2 times root 2 is root 4, so it's -9 times 2, which is -18. And then we just need to tidy that all up. So the 10 plus the 6 on the top is 16. The 6 root 2 add the 5 root 2 is 11 root 2. And then 25 minus 18 is 7. And then neither of those simplify, nothing on the top divides by 7 there. So that would be our final answer for this one. So I've not got any negatives on the bottom this time. And there we go, that's the end of that video. So that is covering the Algebraic Expressions unit of the ASP or GCSE. I will link it below the next one of these revision videos, which is going to be on the Quadratics unit. So looking at solving quadratic equations, completing the square and quadratic graphs and all things quadratics. So please do follow along with these. And again, if you found it useful, please like, please comment, please subscribe, and I'll see you for the next one.